You're looking at a structure that defies the chaos of space. This is our home, the Milky Way, and it's a staggering 100,000 light-years across. That bright core isn't just a light show. It's a gravitational anchor holding 1.5 trillion solar masses in a delicate balance against the expansion of the universe. But we're not staying here. Let's pull back. As we leave our galaxy, you'll spot these smaller neighbors, the Magellanic Clouds, about 160,000 light-years away. They look peaceful, but the Milky Way is actually ripping them apart in a process called galactic cannibalism. It's a harsh truth of the cosmos. Big galaxies get bigger by eating their neighbors. We're moving out to the local group now, a cluster spanning 10 million light-years. It looks like these 54 galaxies are just drifting, but they're trapped in an invisible web of dark matter. That invisible glue is the only thing keeping this island of galaxies from dissolving into the void of the expanding universe. Let's lock onto our target, Centaurus A. It's 12 million light-years away, and it looks weird because it's a cosmic crime scene. This is what happens when a giant elliptical galaxy smashes into a spiral one, triggering a starburst of new star formation. It's not just a galaxy, it's the wreckage of a collision. We're diving straight at that dark band. That's a dust lane 15,000 light-years wide, spinning at over 500,000 miles per hour. Think of it like a heavy curtain made of cold gas and dust. It absorbs visible light, hiding the superheated monster lurking in the center. Let's punch through. We've just entered the halo. Unlike the neat traffic of our solar system, the stars here follow chaotic elliptical orbits, thrown off balance by that ancient merger. It's lonely out here. These stars are separated by trillions of miles of empty vacuum, but it's about to get a lot more crowded. Down here near the equatorial plane, the heat cranks up. Stars are packed thousands of times closer together than near Earth, creating a sky of blinding fire. This is a stellar nursery, where shock waves crush gas clouds until they collapse into new suns. It's beautiful, but that radiation would fry us instantly. And here is the end of the line. We're staring down a black hole with the mass of 55 million suns. That marker is the event horizon, a point of no return where gravity is so strong, not even light can escape. We've reached the edge of the known physics. Are you ready to see what's inside? This looks peaceful, but it's actually the loneliest place in the universe. We're in the outer halo, where the average distance between stars is over 30 trillion miles. That's like living in a house where your nearest neighbor is on a different continent. We're pushing deeper, and we've stumbled onto a cosmic crime scene. That dark band of dust spans 15,000 light-years across. It's actually the wreckage of a smaller spiral galaxy that Centaurus A completely devoured millions of years ago. Here's the weird part. We're traveling faster than light, but everything looks frozen. Space is just too big to see movement. If the sun were a grapefruit in New York, the nearest star would be another grapefruit all the way in San Francisco. We are now officially falling into the trap. We're sliding down the galaxy's gravitational potential well towards a monster the size of 55 million suns. Gravity here isn't just a force, it's a slope, and it's getting steeper every second. Suddenly, the sky is getting crowded. We've entered the bulge, where stars are packed just 60 billion miles apart. If you lived on a planet here, your night sky wouldn't be dark. It would glow with the light of 1,000,000 full moons. Don't let this smooth ride fool you. Centaurus A is an active radio galaxy, which means this empty space should be a storm of deadly radiation. In reality, nothing biological could survive this approach without being fried instantly. The light is becoming a physical weight. The core is 100 times brighter in radio waves than our entire Milky Way. We're seeing integrated starlight, where billions of stars blur together into a single blinding wall of energy. Quick visual detour. Look at that cluster of blue stars. That's an open cluster, a stellar nursery less than 100 million years old. They're a family born from the same cloud, but gravity is loose here, so they're destined to drift apart and be lost to the galaxy. We're looking at a cosmic crime scene. This is Centaurus A, about 12 million light-years from Earth. And it's a mess because it's actually two galaxies crashing into each other. That violent history has left behind a chaotic swarm of stars that we're navigating right now. It makes you wonder, what's hiding in the center of all this wreckage? It's getting claustrophobic in here. We're entering the galactic bulge, where gravity acts like a shepherd, packing old red giant stars into a tight space. The gravity holding this swarm together comes from a central black hole with the mass of 55 million suns. Imagine the entire population of Earth crammed into a single elevator. That's the kind of stellar density we're talking about. That blinding light ahead, that's not a star. It's the active galactic nucleus, or AGN. It's pumping out X-rays and radio waves powerful enough to be detected back on Earth. This is thermal radiation, heat generated by matter falling into the gravity well. It's getting hot, and we haven't even reached the source yet. Look at how fast those stars are moving. Down here, gravity is so strong that stars have to orbit at thousands of miles per second just to avoid falling in. It's a high-stakes game of orbital mechanics. If they slow down even a little, they're lunch. It's dizzying just watching them zip by. We can finally see the structure responsible for all this chaos. The accretion disk. It's a flat spinning disk of gas and dust. The friction inside that disk is grinding material together, heating it up to over 18 million degrees Fahrenheit. That's thousands of times hotter than the surface of the sun, all generated just by stuff rubbing together. We are staring directly into the engine of the galaxy. That black void in the center, that's the event horizon, and it's about 200 million miles across, wide enough to swallow the Earth and the Sun, with room to spare. This machine converts gravity into light with terrifying efficiency. It's the ultimate cosmic trash compactor. See that weird hump of light curving over the top? That's actually the back of the disk. Gravity here is so intense, it's warping space-time, bending light from behind the black hole up and over so we can see it. At this boundary, the escape velocity is faster than light itself, 186,000 miles per second. Cross that line, and you're never coming back. Now, things are getting really trippy. The background stars look like they're melting into rings. This is gravitational lensing, an effect Einstein predicted back in 1915. The black hole is acting like a funhouse mirror, bending the light of the universe around it. It's a reminder that down here, your eyes can't always trust what they see. Check this out. We are approaching a region where gravity is so intense, it actually traps light in a circle. This is the central black hole of Centaurus A. It's massive, packing the weight of 55 million suns into a space 200 million miles wide. We're currently in the photon sphere. If you were floating here and looked to the side, the gravity would bend the light around the back of the hole, meaning you'd theoretically see the back of your own head. Let's get closer. That pitch-black sphere is the event horizon, and it spans about 102 million miles. That's roughly the distance from Earth to the Sun. See that halo of light warping around it? That's called an Einstein ring. It's not a physical ring. It's starlight from behind the black hole. The gravity here is acting like a massive lens, bending the fabric of space-time and warping the image of the universe behind it into a perfect circle. We're diving in now, heading for the point of no return. The gravity here is millions of times stronger than Earth's. But because this is a supermassive black hole, the tidal forces are actually low enough that we won't get ripped apart instantly. But here's the mind-bender. Time dilation. To an observer back on Earth, we'd appear to slow down and freeze at the edge forever. But for us, we're plunging into the dark at normal speed. And that's it. We've crossed the horizon. To escape now, you'd need to travel faster than the speed of light, which is impossible. According to general relativity, every single path forward leads to the singularity, a theoretical point of infinite density where geometry fails, our math breaks down, and the laws of physics as we know them just stop.